Hello, this is the density of a gas pre-lab video. We know density as the relationship between the mass of a substance and its volume. Another way to describe it would be the slope of a mass-volume graph. At a particle level, we can see that high-density materials have particles that are close together. They maybe have more particles or more mass in a given volume, low density being the opposite. For the most part, solids and liquids have fairly similar densities. Solids may be a little bit more dense than liquids on average. You can see some common materials here for both solids and liquids. Generally speaking, most materials are relatively close to 1. Some of your heavier metals are obviously a little higher, closer to maybe 10. And some of your lighter things, styrofoam is about 0.1 grams per milliliter, just as an example. So we've discussed solids and liquids. We haven't really yet discussed gases. And so the question is this: how does the density of a gas compare to that of a solid or a liquid? So for this, we need the volume of a sample of gas, and we need the mass of a sample of gas. Some sample data table, you can set this up however you like. This is just kind of a sample of some of the things you might need to collect. The volume, we'll need volume of the gas, the mass of the test tube, and then the collected gas, and then we can calculate from that the density. Materials and things that you're going to need today, you'll need a test tube with a number 2 stopper. Make sure that the stopper does not have a hole in it. If it does have a hole, we'll need to close that up with tape or something else. You'll need a graduated cylinder. You'll need the electronic balance and then a gas collection trough, which I'll show you where those are at and how we're going to use those. To begin, measure and record the mass of the empty test tube and the stopper. We'll need that later. For the volume, the test tubes aren't marked, and so we need to measure the volume that the test tube holds. The easiest way is to fill it with water and then pour it into a graduated cylinder, and that should tell us how much space the tube can hold. The gas collection trough is a little plastic or metal tray, and it'll have some tubing running out of the bottom. That tubing is going to get connected to a gas outlet, which we have all around the lab. We're going to fill this thing about half full of water. It doesn't need to be much more than that, because otherwise you just end up spilling it everywhere. So about half full. You can see in the video, I'm just filling the test tube with water. I want to fill it slowly. I want to make sure there's no air bubbles trapped in there. I stood it up. You'll want to make sure, just kind of make sure it doesn't fall over, because you're going to lose all the water. We want the water trapped in there because the gas is going to have to push that water out. If there's air, it's going to throw off our result. Once you turn the gas on, you're going to start to see bubbles. You have the test tube slid over the opening. Bubbles are going to start to fill the tube and push out the water. You want the tube full of gas, so we're going to go ahead and just let it fill up all the way to the end until all the water's been pushed out. From there, you can put the stopper back in the tube. The important thing is that you put the stopper in while the tube opening is underwater. If you just take the tube out of the water without putting the stopper in, all the gas will escape and you're going to have to do it again. Once the stopper is in, you can take it out of the water, dry off the outside so it doesn't affect the results, and try to find the mass of your test tube, stopper, and gas. Make sure we get that last measurement of the gas. There might be a few little water droplets inside, but it shouldn't be enough to significantly affect the results here. And that's the lab. Make sure you clean everything up when you're done. Put it away and then complete the classroom assignment reflecting on your results.